So we have a problem here that says that we have a rod spinning as depicted in this diagram over here, counterclockwise, and our rod's length is 2 meters with its mass being 10 kilograms, and it's rotating at a rate of 20 radians per second. And so we have part A that is asking, what is the rotational kinetic energy of the rod? So when we think about the rotational kinetic energy of any object, we can say that the rotational kinetic energy is going to equal 1/2 of the object's moment of inertia times its rate that it's spinning at, also known as the angular velocity. So we have these two variables here, one of which we have been given, the angular velocity, being 20 radians per second. So what we want to find first is the moment of inertia for a rod, the I of this rod. And moment of inertias vary based on what object you're looking at. So a rod's moment of inertia will differ from a sphere or even a hollow sphere. These are all things that you can look up, but we know as a fact that the moment of inertia of the rod that we have is equal to 1/12 times the mass of the rod times the length of the rod, we're multiplying here, times the length of the rod squared. So instead of calculating this individually, we're just going to put this big conglomerate here inside the equation that we have for our kinetic rotational energy. So the rotational energy for our rod is then going to equal 1/2 times this entire moment of inertia, 1/12 times the mass of our rod times the length of our rod squared, and then all times our angular velocity squared. And we have everything that we need now in variables. We have the mass of our rod, the length of our rod, and our angular velocity. So we can just plug all these numbers in and then solve for it. So we have 1/2 times 1/12 of 10 kilograms times 2 meters squared, and then all of that times 20 squared. So we can just plug these into our calculator, and all of this will come out to be 666.66 joules. What a lovely number that we have gotten, coincidentally. So for all this trouble that we went through finding our moment of inertia for our rod, it's not as complicated as it could be for a system of objects rotating. But with this, we can move on to part B of our problem.